Hello everyone. Welcome to the next session on Exbook questions on Kaggle with Learner. So we are talking about question number 5 today. So very quickly, I'll take you to question number 5, which we discussed yesterday. So we said that it is given a positive number n, write a function to return all the prime numbers that are no larger than n. For example, if n is equal to 20, then it returns you 2, 3, 5, 7, 11, 13, 17 and 19. So that is all the prime numbers, and they have given some examples. If you write down 1, it should give you empty. If you write down 2, it should give you 2, and if you give it 30, all the prime numbers till 30 and 40 respectively, and it's a medium one. So this is what I've created. I've created a function called primefactor, which is taking a str num1. Then I'm initializing a list called prime list, and I'm putting in a flag which says is prime is equal to true. So then what I'm doing is I'm running an if loop, and I'm not running an if loop, but I'm running an if statement. And in the if statement, I'm writing down if is instance, that is num1 is type of integer, then I will convert string num1 to a num1. But in each situation, it will be returning an empty list. So if you even try to give it a alphabetical things, this code will avoid you, and it will not run the code, and we'll just get the empty list. So then once I've converted, I write down the prime list empty again, because at the moment this might look redundant in the first flow, but the next time when it will be going into the flow, I require the prime list to be empty. Or do I require it? I think I don't. So I can change this to be empty, or remove this, because we have already initialized it on the top. Then we are going to go for a for loop, in which I'm saying that it will start from 2 and it will go to the number that we have converted plus 1. So it will be going from 2 to plus 1. So if you're num 2 there, it will be going to 3. If you're num 3, it will be going to 4. And then I'm initializing again if is prime is equal to true. That I've done purposely. It's not redundant, because in the loop, when it is there, once it gets false, it will remain at false, but I want to change it back to true every time it comes here in the outer loop, where we are talking about when we are looping in through the numbers. And then I'm running this loop, which will be running from 2 to j, and then it will be finding if my j modulus I is equal to 0. That means that for any number j is divisible by I, which is less than j, then it will give me a 0. And once it gives me a 0, it will say is prime is equal to false in break. So if I find is prime, I'll not do anything. I'll just return the I'll go to the next iteration, or what I'm going to do is, if I find it as a prime, then it will not come to this part here. For all, once the loop has been executed, it will not come to this part. It will break and it will go here. But if it comes here, that means that is prime is equal to true. If there is no number bit from 2 to j which can divide j, then j is a prime number. So 7 is not divisible by anything between 2 to 6. So 2 to 7, in fact, that's what we are talking about. In fact, we are talking about 2 to 6, because 7 divides itself. So that is where the range comes in picture. So it will be going from 2 to j minus 1. So that is how the loop will be running. And I'll be checking if any number divides that. That is it. Anything that gives you remainder 0 means that j is divisible by I. In that scenario, it will give it false. But because if j is not divisible by I or any of the i's, then it will not execute this method. It will directly come here and it will execute this, and then we'll be appending. If that's the case, if prime is equal to true, then prime list dot append is equal to j. So that is where we'll be adding the value of the j into the list. So this loop will go through, and then once it has completed this complete loop, we come out of the loop and we say return prime list. Now this break statement is only for breaking the inner loop. It is not for the outer loop. So if I have to write it on in the outer loop, I'll have to write it directly into the outer loop, and that's how it will break. So this, I created an example, but I wanted to show you a different thing. If I write down hello, and I try to run it, it will give me an empty button because of this statement here. It will check that this is not equal to, this cannot be converted into an int, so it will not run any of the command. It will directly come out of it and give you the prime list. So this part here, which is empty, so it will give you the empty bracket. Now we are checking the test, or we are checking with the Exbook, and if I run this command, I see it is doing a 9 test on this, and we have cleared all of them. So you can see the code. But for tomorrow, let's just start with the example of EB5, which is question number 6 for us. And that's the question where we are talking about a robot starts to move from origin 0, 0 on a 2D plane given a sequence of move in terms of string L for left, R for right, U for up, and D for down. Write a function to tell if the robot returns to the original 0, 0 after the sequence of move. The output of the function is a Boolean value. So that's what we have to do. It's an easy one. We'll work on that tomorrow, but if you get time and if you want to try it yourself better, you can try it and you can leave me a comment on the YouTube as well. So with that, I come to the end of it. I'll be sharing this as usual. I've shared it with everyone. It has been made public, so you can view it. You can work on it as well. So once again, I thank you, and I hope we have moved a bit forward today, or as we are moving a bit forward daily. So once again, thank you and good day. Goodbye.